Hello, guys. Hello, friends. Hello, everyone. Hello, students. Welcome to Unique Global Tutorial. Welcome to the world of mathematics. So, today we're going to continue with the special concept called trigonometry, which we actually started the introductory aspect during our last class. Just a few minutes of recap. During our last class, or being the introductory class, we were able to establish the fact that trigonometry is a branch of mathematics that studies the relationship between the various sides of the triangles as well as the angles of the triangles. And it also uses the six basic trigonometrical functions like the sine theta, the cosine theta, the tangent, the cotangent, the cosecant, as well as the secant, in showing the relationship between the various sides of a triangle. For instance, when you say sine theta is a trigonometrical function which is used to show the relationship between the opposite and the hypotenuse. And then the cosine theta is a trigonometrical function used to show the relationship between the adjacent as well as the hypotenuse. And then the tangent is a trigonometrical function which we can use to show the relationship between the opposite as well as the adjacent sides of the triangles. And so goes cotangent, goes cosecant as well as the secant. The secant, they all shows the relationship between the various sides of the triangle as well as the angles of the triangle. Now, having established that fact during our last class, we proceeded over as well to say that we have six basic types of triangles in mathematics, and that the six basic types of triangle can be classified into two major classes. In other words, we can classify triangles based on the size they possess, otherwise called the lateral classification, or we classify the triangles based on the angles, talking about the angular classifications. And now, if we classify triangles based on the lateral or sides, we will be talking about triangles like the equilateral triangle when the three sides are equal. Equilateral, typical example of the shape is this when the three sides are equal. For instance, we'll be talking about when you say equilateral, it's a triangle that has the three sides equal. We also talk about the isosceles being a type of triangle that has two of its sides. It could be like this. Two of its sides. Two of its sides will be equal. I'm going to draw this. I'm going to draw this. I'm going to draw this. This side and this side will be equal. Okay, let me change this a little bit. The equilateral to reflect now 3. Go. A typical equilateral, a triangle that has three sides equal. The isosceles, a triangle that has two sides equal. This side may be the same thing with this side, and this side is different. Then we also have what we call the scaling triangle when none of its sides are equal. It could be like this. None of its sides are equal. This is different from this side, and this side is different from that side. Then, having said that, just to recap again, I said lateral classification. Under lateral classification, we have the equilateral triangle with three sides equal. We have the isosceles, the triangle that has two equal sides. Or we have the scaling triangle where no sides of the triangles are equal. And then after considering the lateral classification, we'll talk about the angular classifications. That the angular classification is classification of triangles based on the angle they possess. Based on the angle they possess. The angle they possess. Now, when you classify triangles based on the angle they possess, you'll be having what we call the acute triangle. These are typical examples of acute triangle when none of this angle is up to 90. This is not up to 90, this is not up to 90, this is not up to 90. That is an acute triangle. Triangle that has none of its side up to 90 degree. And then thereafter, we also talked about the obtuse triangle. When you have an obtuse triangle, one of its angle is greater than 180. Typical examples, greater than 90. As you can see this is greater than 90. This is greater than 90. If I draw straight, I'm going to be I got 90 from here to here. And when you cross over, means it's greater than 90. Talking about obtuse triangle. A triangle that has one of its side greater than 90 but less than 180. Then we'll also talk about the right angle triangle. The right angle triangle is simply a triangle that has its angle, one of its angle as 90. Right angle triangle, observe it. This is vertical and this is horizontal. The point they made here is 90. It implies that we also have the right angle triangle. Now, our major point of focus will be on the angular classification, focusing more on the acute triangle as well as the obtuse triangle. Previous classes we have considered and we have trashed and provided a solution to the right angle triangle. And now the right angle triangle can be resolved using Pythagoras' theorem, which says that the longest side of a triangle being the hypotenuse, the square of the longest side of the triangle being the hypotenuse, is equal to the sum of the square of, if this is the opposite, square of the sum of the opposite and the adjacent. This is hypotenuse. All I have said is the fact that all right angle triangle can be resolved using Pythagoras' theorem, which we have resolved in our previous classes when we started mathematics on this page. And therefore, that all right angle triangle can be resolved using Pythagoras' theorem. What is Pythagoras' theorem? It simply states that the square of the longest side of the triangle, which is hypotenuse represented with HYP, the square of the hypotenuse being the longest side of the triangle is equal to the sum of the sum of the square of the opposite and the square of the adjacent. This can be used to resolve all right angle triangle such that when you are given a triangle, the first thing that comes to your mind is to observe the triangle closely. Immediately you detect that it's a right angle triangle, straight away, the solution to it is Pythagoras' theorem. The square of hypotenuse is equal to the sum of the square of the opposite and the square of the adjacent. Now, what comes to mind? If we find out that the triangles we're dealing with is not a right angle triangle, that means this point is not 90. What comes to mind if the triangle you're dealing with is of this shape? Of course, none of this is up to 90. This can be regarded as an acute triangle. Or the triangle you came across was of this nature. Of course, okay, let me take it a little bit forward. Let me bend it like this. Of course, this is not 90. This is more than 90, as in the case of obtuse triangle. For a better understanding, when you are given a questions on triangles, and you find out that the triangles you're dealing with is right angle triangle, as in this case, whereby this is angle 90. I said the solution is Pythagoras' theorem. The square of the hypotenuse is equal to the sum of the squares of the other two sides, and it can be resolved with that alone. But whereby it happens to be acute triangle, as in this case, or obtuse triangle, as in this case, you can never use Pythagoras theorem. What then comes to mind? What then comes to mind? The solution that will come to your mind is the sine rule and the cosine rule. The sine rule and the cosine rule. What is the formula for sine rule? Sine rule says that A is A all over sine A is equals to B all over sine B equal to C all over sine C. What I'm saying is this: if it happens to be an acute triangle you observed, or obtuse triangle, the formula that comes to mind is sine rule. This is a sine rule. Sine rule. This is a sine rule saying that A all over sine A is equals to B all over sine B equal to C all over sine C. But not all the obtuse and the acute triangle that the sine rule can resolve. And when it cannot resolve it, what then do you use? You use what we call the cosine rule. And the cosine rule is simply saying there are three in numbers. Cosine rule are three in numbers. You have to learn them and store them in your brain. The cosine rule is saying that if a square is equals to b square plus c square minus 2bc cos A, capital letter A. Don't forget, this is the cosine rule. Cosine rule. The first formula or the first equation there is a squared equals to b squared plus c squared minus 2bc cos A. Then the second formula that comes to mind is b squared equals to, remaining two alphabet are a squared plus c squared minus these 2ac cos 2ac cos the b. The b you started with, observe it. Side B and angle B. Side A and angle A. So the last formula on cosine rule will be c squared equals to b squared plus a squared minus 2ab cos c. You can as well bring a square first. Bring a square first before b. The formula is as simple as ABC. When sine rule cannot resolve acute and obtuse triangle. Another formula that comes to mind is the cosine rule. What is the cosine rule saying? Here is it. If you start with side A,